All right, today we're going to finish the notes on cross sections. You should have the front side filled out. We're going to move to the back. We're going to look at these two problems right here. We're going to go a little bit of old school today, and we're going to talk about how to visualize these without a computer. We're going to actually use some shapes that I used to use when we did these problems long, long ago, BC, before computers, as opposed to 2000 BC, 2000 before computers. Find the volume of a solid whose base is bounded by the lines, or it tells you they're lines, that's nice, these three lines. If the cross-sections are squares, that's the important part. The fact that it says cross-section, squares, and perpendicular to the x-axis. Those are the three most important parts of this problem, besides the equations of the lines, of course. I'm going to go underline those as well. Okay. When you do these problems, what I want you to do is I want you to draw a picture of a bird's eye view, like the one that was in the top left corner of the computer screen yesterday, of the base and what the direction that the pieces will be going, as well as a front view of one of the slices of the piece. Okay? So we need to over here draw an XY axis. You need to go out at least 4 in each direction. We're going to draw this by hand, but end up putting it in the calculator to solve it. Okay, first line, y equals x minus 4. On the AP exam, they may give you this problem, no calculator, and just ask you to set up the integral and not solve it. That tends to be a common thing that they do. These kinds of problems, you will see at least one on every free response. I have not seen a single year go by where they have not given you a problem like this, where part A is asking for find the area of the certain region. Part B is asking for cross sections, and part C is asking for what we call volumes of revolution, which is what I'm going to teach you after spring break. Okay? That tends to be the pattern. Sometimes it's with a calculator, sometimes it's without. If it's without a calculator, they want you to be able to draw the base by hand and just set up the integrals. If it's a calculator, they want you to go ahead and put it in the calculator and solve it out. Okay? So, the line y equals x minus 4 goes through negative 4 right here. What's it going to go through on the x-axis? 4, 0. It's going to go through this point right here. So we're talking about this line right there. This is y equals x minus 4. Then the next line is 4 minus x. How is it going to look different? It's going to be the reverse. It's going to go through the point 0, 4. Come down and go through this point down here. 4 minus x. And the third side is x equals 0. And I cannot tell you how many AP students I have seen who don't know what x equals 0 is. Is it the x-axis or the y-axis? It's the y-axis. It's the y-axis. So, what shape is the base today? It's a triangle. What was it yesterday? Circle. It was a circle. Okay? Now, yesterday's base was all one equation, and that's going to play into how we solve this problem. Okay? So, the cross sections are going to be squares. So, I need to draw a square. And they're going to be perpendicular to the x-axis. So that means the squares are going to go this way. Agreed? So let's see if I have, here are some little bitty squares. The squares are going like this. Do y'all see my square? Now it's tilting it a little bit so you can see it. They go from squares this big down to teeny tiny squares, up to even bigger squares once they hit the x-axis, the y-axis, excuse me. Are you with me? Okay. So now, before we set this problem up, is this going to be a dx or a dy? It is a dx because yesterday I mentioned that if it says perpendicular to the x, it's a dx. After you draw your square, I'm on the side of the square that is what is part of the bird's eye view right here. And if you want to do it in a separate color, basically saying this red side is the same thing as that red side. Okay? Because it's important to know what part of your piece is sitting on the base. What is the formula for the area of a square? S squared. Okay? Now, here's the big question. How long is S? How long is that red line I just drew on the bottom of the square? No, it can't be 2y because there are two different y's up there. Two of which y? The green y or the purple y? Not exactly. Okay. This specific problem is symmetric about the x-axis. Agreed? Okay. But I want to pretend for a minute that maybe it's not. Okay? Some people may be thinking, well, I'll just do this y and double it. Well, yeah, you could in this scenario, but let's talk about what if you couldn't. What if you couldn't do that? Okay. The distance from here to here is equal to the y value of which curve? The green one, which I'm going to call, let's call that top one y2. We'll call that y2 to distinguish the two. The distance from here down is y1, all right? But it's going to be a negative value. So would it be y2 plus y1 or y2 minus y1? What do you think? It would have to be y2 minus y1 because the y1 would come out to be a negative. You would need a double negative to turn it positive. Does that make sense? Yeah, you're using the top minus bottom scenario pretty much is what you're doing.
And you can plug it into the calculator?
Yes, we are going to plug it in the calculator in just a minute. Oops, I didn't mean to draw that. So in this case, it's going to be y2 minus y1.
How do you know how tall this was?
How do you know how tall the what?
This is finding volume, but you're just dealing with the 2D obvious.
The volume is, like it was in the cylinder yesterday, the area of one slice times the height of the slices. Okay? The height is, it's turned on its side. So think of a cylinder turned on its side. It's one slice times all of the slices together. This is all of the squares together. It's the area of one square times all of the squares together. And the way to get all of the squares together is the integral. The integral adds all the squares up. Yes, Nikki?
Can you do absolute value that makes more sense to you?
You
Or adding up the y's?
You could, but you can't. How would you write it down?
Y2 plus
y2 plus the
absolute value of y1.
absolute value of y1. Would that work? I'm trying to think if that would work all the time. That's what I'm going through in my head. I think that the AP graders would prefer that you do y2 minus y1, or top minus bottom like we did on the area, okay? Because it will definitely work every time, okay? All right, so now, integral. We have to do an integral to find the volume, because that adds up all the squares. First thing I want you to write down is it a dx or a dy? In this case, it is dx. The reason I have you write that down first is because that tells you whether the limits of integration should be x's or y's. And in this case, since that says dx, they have to be x's. So, where do the x values go for the base? Where do the squares start? Where do they end? 0 to 4. The squares start at x equals 0. They end where the two lines cross at x equals 4. Okay? In here goes the formula for the area is s squared. Now you can write s squared if you want to, but I'm going to skip that step and put in the y's. So it's going to be y2 minus y1 squared. Does everybody see how I got that? Okay? But because these are y's and this is x's, I cannot integrate it. I can't put it in the calculator yet. I've got to do some more math to it. So y2 is 4 minus x minus y1 is x minus 4, and I'm supposed to square all of that. So I need to put another big parentheses around the whole thing and square it, dx.
Couldn't you put in the calculator that was y too much?
If you had them typed into y equals yes. If you have, and also for the AP exam, if you have defined on your paper somewhere y1 equals this line, y2 equals this one, and then you could write your integral y2 minus y1 dx and be fine. Okay? So I'm going to take my calculator now. I know it's kind of dark. I should have turned that lamp on. I don't want the other lights on, though, because my head still hurts. Math 9, 0 to 4. Parentheses 4 minus x close minus parentheses x minus 4 close squared. Oops, I forgot to close again. Close squared dx. And you should end up with this decimal, 85.3 repeating, or 256 over 3. Now let's do the last problem. Silently read the last problem and see how it compares to the one we just did. Same thing exactly, except it says perpendicular to the y-axis, which means it's going to be a dy. So please draw on your notes this exact same drawing, except for drawing your bird's eye view going, changing this piece right here. So go ahead and start redrawing that. Okay, do y'all have your picture drawn? It says it's perpendicular to the y-axis. What? I will show you. Hang on, let me get one of my baby squares out of here. Okay. Yes, or you can double it. We're going to double it. I drew my picture too small. I can't find a square that's small enough. Oh, yes, I can. Here we go. Dropped you again. Where'd it go? Here you are. Baby squares. So here's my baby square. Sitting in it right here. See it? Standing up in the thing. Right there. Going from teeny tiny squares up here down to big squares. And then teeny tiny again. Now, why did I draw my line up here? It doesn't matter. I could have drawn it down here, but I like quadrant 1. In quadrant 1, everything's positive. I'd rather stay where it's positive. So I drew it up here. Okay? Now, will the squares be symmetrical in size on the top half of this graph as compared to the bottom half? Yes. Now, because of the fact that the squares touch the green line until I get to the x-axis, and then they touch the purple line, if I do the volume of the whole thing, I'm going to have to do 2 separate integrals. But because I know that it's symmetrical, I can actually do 1 integral for just line and double it. Okay? So that's what I'm going to do for this problem. Okay. So I have drawn my picture. I have drawn my square. Formula for the area of S squared again. But this time, what is S? X. Okay? The answer is yes, it's x. If the side of your square goes horizontal, it's going to have something to do with an x. If the side of your square goes vertical, it's going to have something to do with a y every time. And in this case, because it just goes from the x-axis out, it is just an x. Because the length of this side is equal to the x-coordinate on this line. If the side happened to be here at 3, it would be a 3 by 3 square. If the side happened to be here, it would be a 1 by 1 square because the x-coordinate right there is 1. That's what determines the length of the side. Now, I'm going to add from the line y equals 4 minus x so I know which x-coordinate we're talking about. Okay, so when I set up my integral, because it's a dy, I want to write the dy down first. Okay, now remember we're only doing the squares that touch the green line. Since it's dy, these two numbers have to be y values. For the green line squares, what do the y values go from? What to what? Is it negative 4 to 4? 0 to 4. 0 to 4. Does everybody see that?
Why are you having to do it as separate? Yeah, that's what I think about. Like how you said you're only focusing on the green line. Like why can't you focus on those?
Because the x, all right, when I plug in, okay, I'll answer your question in 30 seconds, okay? Now, what is going to go right here? What am I going to write right here?
2 times the x squared.
X squared, right? Because the side is x. Now, in answer to Aranza's question, why do I have to do it separately? Because the x-coordinate based off of this line is going to be a different x-coordinate than the ones based off of the other line. Okay? Because I have to change this thing to a y in order to integrate it, I have to know which line I'm going to use to rearrange to solve for x. Because I'm using the line y equals 4 minus x, I need to take that line and solve for x so I know what to plug in here. Does that kind of help? Mm-hmm. Okay. Now, if you solve that for x, what are you going to get?
X equals 4 minus 4.
Negative x equals y minus 4, so x equals 4 minus y. You all agree with that? Or negative y plus 4, same thing. So this is what gets substituted in here. But, oops, I forgot the 2. Why do I need the 2 again?
Because you're doubling it.
I'm doubling it. I'm only taking the volume of the top half of that.
But what if it's not congruent on both sides?
Then you're going to have to do 2 separate integrals.
And then you just add them?
Yes, you would add them together. Exactly. So I'm going to move down here because that's kind of in my way. 2 integrals 0 to 4 of 4 minus y squared dy. And now you can use your calculator. You can type this in as a dx or a dy if you have an 84. If you have an 83, you have to do dx. So 2 math 9, 0 to 4. I'm going to do it with x's. Parentheses, 4 minus x close squared dx. And I get this, 42.6 repeating, which is 128 over 3. Okay. Somebody asked me a very good question first period, and I want to address it on the video, and I want to address it with you. The question was, do I have to write the 2 here, or can I go ahead and just multiply by 2 when I'm done? And the answer is you really need to write the 2 here, because that is the true setup of this problem. There was a question on your test that asked about the average temperature over a certain amount of time, and I need to address that later off the video. But it was a situation where you integrated and then you divided by however many hours it was. If you didn't write the fraction in the front, I didn't count it wrong, but that fraction really needed to be in the front, the 1 over b minus a. Some of you didn't put it, but it is part of the average value equation. So if you're going to be multiplying by 2 at the end or dividing by 8 or whatever, you need to go ahead and put it down at the beginning, okay? so that the reader knows that's what you plan on doing. Okay? Do you have any questions on this? Yes, ma'am.
Half of the volume of, like what we did before, is half of the volume of the burning volume of the axis.
It is a coincidence, and it has to do with the fact that it's an isosceles triangle. Okay? I can't tell you any more than that, but it is a coincidence. It's a coincidence more than anything else. Yes?
I don't know.
Okay, I'll answer that after the video. Are there any more questions about this note? So get out your worksheet and a clean sheet of paper and follow along as I do this. Okay, we've got to keep that in view. There we go. Numero uno. Okay, we're going to do this one just like we did the two examples. Okay, and I'm going to write quickly so I can get it all in. I didn't record this last period. I want to record it today. Okay, we ready to go? We have a solid whose base is a circle of radius 1. They don't even give us an equation. So, I need you to draw this circle on an XY axis because I need to see which way it is perpendicular. So I'm not going to mark anything off. I'm just going to draw a nice little circle right there. This is just like yesterday. The base is on circle with a base. Base is a circle of radius 1. Excuse me. Okay. If you read the next sentence, it can be a little bit confusing. It says cross sections taken perpendicular to the base and parallel to the y-axis. So if it's parallel to the y, it's perpendicular to the x. So this is going to be a dx problem, even though it says y-axis. You've got to read carefully, which means it goes like this. Oh, okay. The radius is 1. Okay. So my shape are rectangles. So I'm going to draw a rectangle, and it tells me that the height is 1. So I'm going to draw 1 next to the height. The next thing you need to do is write the equation for the area of a rectangle. Now, since they use the word height, what formula do I want to do? Base times height. Anytime they talk about a formula, use height because they're standing up anyway. Let's think of it that way. Okay. I know that the height is 1, so I'm going to write h equals 1, and it's 1 all the time. The base is the part that's sitting on the base. The base of the rectangle is sitting on the base of the circle. How long is this? Is it 2 all the time? Okay. Is it going to be an x or a y?
Y.
It's going to be a y of some kind. It's y up and y down. Now you can't do y2 minus y1 because it's the same graph on both top and bottom. So we just put 2y because it is not up as it is down. Okay? So then the integral will be a dx. What are my limits? -1 to +1 because the radius is 1. This is -1, this is +1. The squares go across this way. And so I just put in base 2y times height 1. And I'm going to stop right there because the bell's about to ring. You know how to switch it over. You got to write the equation of the circle, switch it around, and go from there. We're going to do more of this tomorrow.